Oxygen. It's the stuff of life. Without it, we're living on borrowed time. Each year, worldwide, 15 million people suffer a debilitating condition when the brain is starved of oxygen. They suffer a stroke. Of those 15 million people, 5 million will die, and another 5 million will be permanently disabled. The European Stroke Network, that unites 30 research teams from 14 European countries, was established to drastically reduce those numbers. Today, the network represents the greatest effort in the fight against strokes worldwide. Researchers like Professor Ulrich have come to understand that time is the most important issue when a stroke strikes.
Time is running. That means that all kinds of things happen that kill cells, that destroy cells. And the faster you do something against it, the better.
Typically, a stroke occurs when a blood vessel supplying the brain becomes blocked. It's a medical condition known as thrombosis. Starve the brain of oxygen, and very quickly parts of the body which it controls will feel the effects. Common symptoms include difficulty in moving limbs, slurred speech, and problems with seeing. Understanding how severe the stroke is requires examining the brain as soon as possible.
Imaging of the brain in stroke patients is extremely important because it tells us whether it is a stroke, it tells us where the stroke is. It can also tell us whether the vessel is still occluded and whether we can open the vessel.
Doctors do this by using magnetic resonance imaging. The technique allows them to see the soft tissue of the brain in detail.
We can look at the biochemistry of the brain, for example. We can try to understand what the mechanisms are that kill brain cells or that save brain cells.
It's a powerful technique for analysing patients who can reach hospital quickly. But if you can't, you're in trouble. So doctors are turning to a new innovation, telemedicine. Audio-visual equipment installed in a telemedicine ambulance allows a stroke specialist in a hospital to communicate with ambulance personnel and examine the patient en route.
Telemedicine in some parts of Europe is already being used, in particular in areas where there are no hospitals nearby. As always, time is brain, so everything that you can get earlier in stroke is the better. So if we are able via telemedicine to get therapy into the ambulance, this would be a breakthrough.
Professor Tadeusz Wieloch and his team in Sweden are also part of the European Research Network project and are interested in treating stroke victims before they reach hospital. They're focusing on a critical factor. After a stroke, it's important to keep a cool head, literally.
It was shown 20 years ago that a modest cooling of the brain provides a robust neuroprotection or brain protection against damage due to either cardiac arrest events, cardiac arrest patients, or in stroke patients.
Tadeusz has helped develop a device for cooling the brain. It's called the Quick Cool Nasal System.
The most important part is this balloon, which is filled with cold solution, and this balloon is inserted into the nasal cavity on each side, in each nostril, like that. And you can appreciate here the nasal cavity where when the balloon is filled with cold water, it will cool both the brain as well as the rest of the body.
However, for the vast majority of stroke victims, it may be hours or days before they reach a doctor.
The question is, can we do anything beneficial for those patients? We know that the brain is constantly reforming itself, and even a stroke patient that is untreated recover spontaneously, but the recovery is slow and incomplete.
However, Tadeusz and his colleagues have revealed something intriguing which can help speed up brain repair. The findings were borne out by studies with rats. Rats which had a stroke and then were placed in a stimulating or enriched environment, one which challenged them to think, recovered more quickly than rats that didn't have to use their brains. And it turns out that what's good for rats is good for us too.
So in humans, the enriched environment we have in the experimental setting would be a relevant rehabilitative therapy. That is training your muscles, listening to relevant music or speech, interaction with your friends, everything that makes an effort to the brain. So with the knowledge from the enriched environment rats, what happens in these brains will provide us with clues to new pharmacological treatment.
New treatments would be a real breakthrough because currently there's only one helpful drug. It's called TPA, and Professor Stephen Mears has been researching the best methods of using it.
TPA, or tissue plasminogen activator, is the only available drug that we have at the present time to treat stroke. And this drug can be very effective if given early, shortly after a stroke, in a time period now up until 4.5 hours after acute stroke.
The group have discovered an ingenious way of improving the identification and treatment of blood clots within the brain.
We are particularly interested here in how we can use ultrasound to treat first acute stroke. What we have learned is that through the application of ultrasound and what we call microbubbles, we can enhance the effect of TPA. That means we can make it work much faster by getting the drug faster into the clot and allowing it to work.
And that's not all. Ultrasound can be used to burst the microbubbles, delivering mini explosions, helping to dislodge the clots.
Even more exciting, however, is our new finding that just the combination of ultrasound and microbubbles alone are capable of dissolving clots without TPA.
And that's useful, because although TPA is an effective drug, it can have some toxic effects and can't be given to patients with internal bleeding. It's hoped that the ultrasound technology can be incorporated into a compact unit, small enough to be carried by a doctor or in an ambulance.
So that we would actually have the opportunity of treating patients on the way to the hospital with this new therapy, increasing the chances for patients to get better and to reduce disability.
But the future holds even more promise for the sufferers of stroke. One of the most ambitious projects of this research network involves the work of Professor Olle Lintvall.
The basic principle of what we are trying to do is to replace the cells that have died following a stroke with new cells. And that can be done by production of new nerve cells from the brain's own neural stem cell.
The astonishing technique aims to grow the stem cells in cultures in the lab and then place them inside the brain of a stroke victim.
So, in fact, what we do by implanting the stem cells into the stroke-damaged brain, we are giving the brain building materials which we hope that the brain will be used to reconstruct the damaged circuitry, to rebuild the network which was damaged due to the stroke. And ultimately this will lead to the recovery of the function which was impaired because of the stroke.
Such a revolutionary theory initially met with a degree of skepticism, but there's been astounding progress in this area.
Well, 30 years ago, when I started trying to repair the brain, this was science fiction. No one could believe that it would be possible to replace cells in the brain that transplanted immature nerve cells they can survive, they can grow, and they can form connections, and they can also have functional effects in the brains of 50, 60-year-old people.
It's incredible to think that soon, through the work of the European Stroke Network, it might be possible to provide the most complex object known to man with a self-repair kit, which will be great news for those who suffer strokes.